In lesson 8, we are going to talk about the perpendicular bisector theorem. So we're going to convince ourselves that what we've conjectured about perpendicular bisectors must be true. So we talked about perpendicular bisectors in Unit 1. So go ahead and take a look at 8.1 and determine which one doesn't belong. So you could have come up with a variety of reasons here and for which one does and doesn't belong. So maybe you said A doesn't belong. Okay, so maybe you said A doesn't belong. It's the only one with the line L. Okay, with L horizontal. Okay, so L being the only one that's horizontal, or it's the only one with L is horizontal. It's the only one where the lines aren't necessarily perpendicular. Okay, could have come up with some other reasons there potentially. For B, maybe you said it's the only one with a 90-degree angle marked. Maybe you said it's the only one with exactly one angle marked. Okay, could have come up with some other reasons, but maybe you came up with those. For C, maybe you said in this one, it's the only one with congruent angles marked. Or maybe you said it's the only one with two angles marked. Again, maybe you came up with something else. And D, a couple examples or a couple reasons you might have said it's the only one with symbols describing the diagram. Okay, so this K perpendicular to M here. And maybe you said it's the only one with K and N for the lines. All right, so let's take a look at 8.2. What do you notice and what do you wonder in this one? So take some time just to look at that. But just what do you notice? What do you wonder there? So again, could come up with a variety of different things here. So maybe you said some of these things. It's a triangle. Segment PA is congruent to segment PB. Angle A is congruent to angle B using isosceles base angles theorem that we just learned about. Maybe you said there's, just notice there's a dotted line. Okay, or maybe you wondered, is the dotted line a line of symmetry? Is the dotted line the angle bisector? Okay, of angle APB, that top angle? Is the dotted line the perpendicular bisector of AB? Okay, could have come up with a variety of other things, but maybe those are a couple of things that you noticed and a couple of things that you wondered when looking at this diagram. So in 8.2, we're going to see that we've got Diego, Jada, and Noah who were given the following task. So their task is to prove that if point C is the same distance from A as it is from B, okay, so we can see it marked here, then C has to be on the perpendicular bisector of AB. So at first they were really stuck. Noah asked, how do you prove if a point is on a line? Their teacher gave them a hint and said, another way to think about it is to draw a line that you know C is on and prove that that line has to be the perpendicular bisector. So they drew a line through C. Okay, so just drew a line through C. And then they thought about their pictures. Okay, so you drew this auxiliary line on here, just drew it. And now you're going to see their different approaches in your book. So read each of their approaches and then determine something that the student understands about the problem. And then what the student should do next to continue on in their proof. So if we read this, we can see it says Diego's approach is that he drew a line through point C that is the perpendicular bisector of AB. So he said, all right, I'm going to draw this line. It's going to go through here, and I'm going to define it as the perpendicular bisector. So you see that he drew the markings on to show that he had drawn the perpendicular bisector, a right angle, and split up AB into congruent pieces. So then he said C is on it, so that proves that C is the perpendicular bisector. Jada's approach is, I thought the line through C would probably go through the midpoint of AB. So I drew that and labeled the midpoint D. Triangle ACB is isosceles, so angles A and B are congruent. And AC and BC are congruent. So AD and DB are congruent because D is the midpoint. That made the two triangles congruent by side angle side. So she said she also knows that it's isosceles. And so she said A is congruent to B. And then she said AC is congruent to CB is her idea. So then that would give her side angle side. So I know that angle ADC and BDC are congruent, but I still don't know if DC is the perpendicular bisector of AB. Noah's approach is that in the isosceles triangle theorem proof Mai and Kyron drew earlier in a different lesson, they drew the angle bisector in their isosceles triangle, so he's going to try that. So I'll draw the angle bisector of ACB, marked the angles congruent. The point where the angle bisector hits AB, I'm going to label as D. So triangles ACD and BCD are congruent, which means that AD and BD are congruent after I prove the triangles are congruent by corresponding parts. So that means B is the midpoint and CD is the perpendicular bisector. So go ahead and relook at those in your book and try to decide what's something that the student understands and what's something that they could do next to finish proving that it's the perpendicular bisector. Is there any holes in their logic? Is there anything that they did incorrectly? So some things that you might end up wanting to say to Diego. Okay, so if we were just looking at Diego's here for a second. So remember that Diego just drew the line through C and said that it was the perpendicular bisector of AB. Okay, so some things that you might say to him is that you know, it's a good thing that he knows what a perpendicular bisector is, that he was able to mark that on the diagram, okay, with a right angle and that it goes through the midpoint. Okay, but the question here is, how do you know that the perpendicular bisector of this segment is definitely going to go through C? Okay, does it have to? Okay, and so let me just draw kind of another case. So if this, is the midpoint, so here's the perpendicular bisector of this side here. So the wonder here is, how do we know that the perpendicular bisector is going to go through C in an isosceles triangle? Does it have to? Okay, how do you know that that segment is going to go through C? So that's one thing you could say to Diego. And so some possible feedback for Jada. Okay, so let's revisit Jada's. So Jada thought the line would probably go through the midpoint, so she connected C to the D. and defined D as the midpoint. So when she drew her line, she said, all right, this line, it's going to go through the midpoint, so here's the midpoint. And then she kind of thought through the rest of it. It's isosceles triangle. Okay, so I know that these angles are congruent. I know that these sides are congruent. So there I have that side angle side that we've looked at before. So again, with this one, okay, some feedback that you could give is it's good that you thought of side angle side because we've done that before. And that you show that you have two pairs of sides and one pair of angles to use. Okay. So could we show that these angles right here are congruent? Okay, so could you show that through a 180-degree rotation, okay, or whatever, that these angles right here are congruent? Okay, being that they're a straight line and they total 180 and they're congruent, because now you've talked about proving the triangles are congruent. These would be corresponding, so they would be congruent. So could you reason through that they would have to be equal and therefore 90? All right, then Noah. Okay, so some feedback that you could have for Noah. So remember, Noah drew in the angle bisector. So Noah said, I'm going to start with the auxiliary line as the angle bisector. Just mark up point D here. And then knows that the triangles are congruent. Okay, or says that the triangles are congruent, which means that D is the midpoint. So it's good that he thought about using the congruent triangles. Okay, which triangle congruence theorem could he use? Because he just goes and says that the triangles are congruent, but doesn't actually justify with a theorem why. So what triangle congruence theorem could he use? So remember, we've talked about side angle side and angle side angle. So which one could he use in this case? Okay, how can he go about showing that CD and AB have to be perpendicular? Because he talked about if he proves the triangles are congruent, then he knows this is the midpoint. So that gets him the bisector part. But how does he ultimately know that this angle is 90 degrees? So he hasn't shown or proven what theorem he's going to use to prove the triangles are congruent, or how he knows the 90-degree angle. And could Noah do that? Certainly. Okay, he could, because we would know the sides are congruent. So this congruent to this by isosceles. And then we know this CD is in both triangles. And then we've got the angle between. So if you kind of look at this one, okay, just kind of look here. That's what you've got on the left triangle. And this is what we've got on the right triangle. Whoops. On the right triangle. So then those two are certainly congruent by side angle side. So again, how could we get these 90 just like Jada needed to do, thinking about that they total up to 180 and they're exactly the same measurement. So it's two equal angles. So dividing by 2 would get us 90 degrees. So then using those ideas, kind of whichever one you liked, okay, think of ways that the students can make their explanations better and write your own explanation. Okay, so use one of their approaches. Okay, so use either Diegos, okay, where you're just going to draw a line, okay, that perpendicular line down the, you're going to draw the perpendicular bisector and then somehow you need to prove that it goes through C. You could use Jada's approach, okay, drawing it at the midpoint, so connecting CD to the midpoint, or sorry, C to the midpoint D, and going that way, proving the triangles are congruent, talking about the 90. Or Noah's, drawing the angle bisector, needing to prove the two triangles are congruent, and then get the 90-degree angle in there as well. So rewrite one of their explanations, okay, and just try to write it better using the advice we just talked about and things that they were missing. You can pick any approach that you want. Okay, then in 8.3, so let's take a look at this diagram. So what statement is this diagram illustrating? So what are some words that we could put to this diagram? So this one is talking about if a point is on the perpendicular bisector of a line segment, then the point must be the same distance. Okay, so how is this different than the last one that we had? Okay, so the last one was if a point is equidistant from the endpoints, then that point has to be on the perpendicular bisector. Okay, so if we've got this point equidistant from these two, then that point has to be on the perpendicular bisector. This picture, okay, so if we had this, then we're trying to prove, is this the perpendicular bisector? On this one, we know this is the perpendicular bisector. Okay, so HG is the perpendicular bisector. They're showing us that it's hitting the midpoint and we've got the 90-degree angle. So this one is trying to get us to say, how do we know that EH is congruent to HF? So this one is the backwards version. So this one, point, we already know is the same distance from A and B. How do we know that this line right here is the perpendicular bisector? Here, have the perpendicular bisector. How do we know this point is the same distance from E and F? So go ahead and look in your book, and so if point P is on the perpendicular bisector of AB, prove that the distance from P to A is the same distance. So in your book, just make a diagram for the statement. So just like I did on that last screen, so just draw yourself a triangle. You know that you have the perpendicular bisector. So we know when we draw this next line that this is hitting at a 90-degree angle. And we've got the congruent lengths here. And then this would be P. So then you can label this point, you know, whatever you want. So if you want to label this point C, that's fine. So then go ahead and write a rough draft or write a draft of a proof that would prove that AP ultimately is congruent to PB. So when you're looking at your proof, okay, so the idea here would be that you're coming up with something that will prove that the two triangles are congruent. So kind of your plan would be to prove that the triangles are congruent. Okay, and maybe you're noticing that you're going to do that through side angle side. Okay, because you're saying, all right, this is a 90-degree angle, so this is probably a 90-degree angle. And I see PC is in both triangles. So I'm noticing that I've got each triangle having this marked, this as a 90-degree angle, and this side. So needing to prove the triangles are congruent by side angle side. And a couple of things that you need to talk about would be how you know that PC is congruent to PC. So putting words to that. And then also, you know, that this angle is a right angle. So how do you know those angles? Okay, so angle ACP is equal to angle BCP, and that both of those are 90. Or both of those are congruent to each other. Okay, and then once you've gotten the triangles are congruent, then you would want to talk about that AP is congruent to or equal to PB. And why is that? So once the triangles are congruent, then you know that the corresponding parts are. So that's kind of just talking through a plan for your proof. So now you'd be putting that pen to paper. Okay, so how do you know? And how did you know this? Okay, so you'd also need your segment, your AC in there. Congruent to CB, how do you know that? And so those things are going to kind of be from the definitions up here. Okay, so as you're starting to write your proof, okay, so you could say first, I know that segment AC and segment CB are congruent because PC is the bisector of AB. So we know it splits it into two congruent statements. Then I also know that angle ACP and angle BCP are 90-degree angles because PC is perpendicular to AB from the perpendicular bisector. So they are congruent since they are the same. Okay, and these are just my words. You can have it differently than this, but this is the idea that you're going through. Okay, and then you would continue on, okay, about how did you know PC was congruent to PC, that it's the same segment, ultimately proving, you know, the two triangles are congruent by side angle side, and then saying AP and PB are congruent because they're corresponding parts of congruent triangles. Okay, so what's the same and what's different about these two statements? So if point C is the same distance from A as it is from B, prove that C must be the perpendicular bisector. If point P is on the perpendicular bisector, prove that the distance from P to A is the same as the distance from P to B. So what's the same about these and what's different? Okay, so they're giving you kind of this if part. This is what you know. Okay, so this is the information that you know or are given as facts to the statement or facts to your case that you're trying to prove. So we know this. This is details that we know. And then the end part, which is called the conclusion, that's what we're trying to get to. Okay, this is what we're trying to prove. Okay, so prove that C has to be on the perpendicular bisector. Okay, so what we're trying to prove. So these are flip-flopped in the statements, right? So in this next one, we know P's on the bisector, and then we're trying to prove the length. Okay, so prove P is the same distance. So if I were to draw these two diagrams with these color coding, okay, for this first one, we know that C is the same distance from A as it is from B. So what we're given is that this is congruent to this. Okay, so we know C is the same distance from A and B. Then you want to prove that this dotted line is the perpendicular bisector. Okay, so you are trying to prove that this has a 90-degree angle. And let me change the color of these vertices too here. So what you're trying to prove in this one is the blue stuff. Okay, so you're trying to prove that these are 90-degree angles and that these two pieces are congruent when you're given the red. Okay, and then in this next one, okay, and I'm just going to take this and duplicate it. In this bottom problem, you are given this part. Okay, so you're given the perpendicular bisector, and you are trying to prove that those two sides are congruent. Okay, so they flip-flop what's given and what's trying to be proved. All right, you can write this in your reference chart, so you can pause, get this written down. And then you can pause and get this written down. And then you can read through your lesson summary in your student workbook and see all of the details about what you looked at today.